Well, Gilles, this is the moment you've been waiting for. Finally, we get to the sea. And at sea, as we all know, you don't see what's below the seabed, but you also don't see what's at the seabed. So there's a difference with terrestrial geology for sure. Well, I already talked about the two important fields of application for coastal and marine geology, and their coastal vulnerability first and offshore wind. And for different reasons, pan-European geological information relevant to these issues, for example from EMODnet Geology, has been mostly descriptive. We've been really focusing on making maps that look kind of uniform and not necessarily fit for purpose, making it difficult to meet those policymakers on the other side. So this makes use by non-geologists and especially in decision-making far from straightforward. And the aim of GSEU is to provide this intuitive fit-for-purpose project that can be used to explain vulnerability, to explain suitability on the basis of geological and especially subsurface knowledge, and thus to predict both construction activities and all the risks and costs associated to it, and also things like management plans and other human influence. So we want to learn, on the one hand, from frontrunners, geological survey organizations in different domains, and we also want to raise our common level, like I said before, of skills and of expertise. And in order to do so, we all together need to jointly move from 2D to 3D. There's just no way around it. And it's both by visualizing it, so making it easier to understand, but also because we have to take it into account to make correct decisions. So, but it's enough about Work Package 5. Obviously important today is what do you expect from us? With that, I would like to say that we'll have two speakers, and let me just see. Our first speaker, I have to turn my page, is Niki Evelpidou, and she will talk about the future of coastal zones. So she'll tackle the first topic that we have, and she is a professor and coastal geologist, coastal geoarchaeologist, expert of citizen science, also at the National Kapodistrian University of Athens. So please come forward.
Thank you very much. Good evening, everybody. It's a great pleasure to be here and an honor to be with you today. Thank you for this, Francesco. I will talk to you about the future of the coastal zone and the role of the geological community in adaptation and mitigation strategies. I guess it goes like that. Yes. So we can understand that the coastal zone is a constantly changing environment, and there are a lot of pressures. Many people live there. In fact, it is the most dense populated area in the earth. And at the same time, it has it faces a lot of pressures because of sea level rise. We talk about that, and also because of our activities, touristic activities, walks, and so on. Based on many different research, it is obvious that until the end of the century, at least the 50 or 60%, depending on which climatic scenario we will use, we will have to face a lot of erosion in our beaches. 50 or 60% of our beaches will face this problem. This will affect humans that live there, the environment for sure, the activities, and so on. Just an example of the beaches that they will face such a problem is the tobolo type, when you have a sand bar connecting inland with the land. In my country, in Greece, we have almost 300 beaches like that. They will all disappear. But it is not only our beaches, it is also our cultural heritage under erosion. Here you may see an example of Dilkos. It is an engineering work of the 7th century BC. It is a land way for ships to bypass a big area. And it is under erosion, and we have to do something for this. And we do this. Whatever it means to you, this is how we protect our cultural heritage. So, what's the existing solution so far? Mainly hard constructions with many problems we all understand. I have listed some of them here. Also, a lot of cement, which means a lot of about emissions. And it is unpleasant. The lifespan is not that good and not really effective. We have the other way, the soft engineering. Sometimes we use beach nourishment, again with many problems. I have listed some of them over here. We have to repeat it almost every year. This is, and this is the answer of the nature. This is what nature is doing, and it protects the coastal zone. What you may see here is a beach rock, which receives most of the wave energy before the wave energy arrives to the coastal zone. For those that are not familiar with the term, beach rocks, it's, let's say, a fossilized beach. It happens with a cementation of high magnesium calcite or aragonite that fills the pores of the sand material, in the beach, whatever this material could be, sand, cells, even man-made artifacts. Let's have a look at this area. It is obvious that it is really vulnerable. It is a lowland. It receives a lot of wave energy, unstabilized sand dunes, a lot of touristic activities, also activities in the land because of the way we manipulate rivers that brings material to the beach and keeps the beach alive, but there is no erosion. The same is also here, with an area receiving a lot of waves, and there is a highly touristic area. Also here, even more vulnerable, with a lagoon behind, which is lower than the current sea level. And the same is here. So what's the common between all these sites? The common thing is the beach rocks you may see here. It is the answer of the nature to the sustainable management of the coastal zone, a sustainable way to protect our beaches. I'm saying sustainable because it is there for at least 5,000 years. We date beach rocks all over the world, so it's pretty old, and with no maintenance, not at all. So, the site you saw before, it was the area that gave me the idea to mimetize what nature is doing, and so this is what we are doing in order to mimic the natural protection of the beach. So it includes fieldwork, laboratory analysis and then combination correlation of data. I chose this picture to show you. This beach rock is 3 meters below current sea level. Have a look how broken it is. It is like that because it receives a lot of energy, wave energy, before it crashes to the beach. So it comes reduced to the beach. Okay. How we may develop beach rocks, how we may create beach rocks. In fact, we just artificially trigger the situation, and then the whole thing is happening naturally. So we use bacteria that live on a particle surface, and they create calcite as a byproduct of their living activity, which is ureolysis. The fieldwork part is very easy. We just collect sediment from the study area and also water. We analyze this in order to find which kind of bacteria exist, and find also the most active of these bacteria. Then we somehow feed it in order to make it more active, and this is how we trigger. And this is how we trigger the whole situation. And just in 14 days, we have the artificially triggered but naturally created beach rock, which is under optical polarized microscopy and under SEM. It has the same, exactly the same characteristic with the natural one. And the same is happening with the mechanical characteristics, which means that we may have a sustainable solution, since we know that beach rocks, the natural created beach rocks, are there without any maintenance. So I think that the geological community can bring some solutions for the adaptation and mitigation of our costs. And we have done so many things about the vulnerability. We know which areas are vulnerable. We know the sea level rise. We know what is happening. We can understand the parameters and the way that coastal zone is reacting to what is happening. So I think it's the time to bring something else in the community and bring our geological knowledge for the adaptation and mitigation strategies of our coastal zone. And I selected to finish with this slide because this is the area that gave me the idea of this kind of protection. Thank you very much.
Thank you, Niki. I think it's very good to see that that obviously nature and geology give us problems, but it also gives us solutions. So it goes both ways, and that's a very good thing to know and realize as a group. So our second speaker is David Moreno Garcia, and he is from DEME. He is a quaternary geologist, knows an awful lot about the North Sea and about geohazards associated with the North Sea, hazards from a long time ago, but also modern ones. And he's building ground models for offshore wind farms for DEME right now. And he will talk about the geological challenges of offshore wind farms. So please come to the front.
Okay, thank you very much for the introduction and for the invitation. I'm very pleased to be here, actually. So I work for DEME, for the DEME group. For those who don't know the company, this is one of the big 5 companies in marine civil engineering. So we do pretty much everything that happens in the sea, but especially, so we're a lot involved in wind farms operations and seating. So I'm going to just talk about, or mostly complain about, all the problems that geologists have when we deal with this kind of project. So, okay, this is just to give you, because I'm a very organized person, so just to give you an introduction, layout. So here, what is a wind farm project? So it's just a simple concept. So we have the wind turbines generators that are connected by cables to an offshore substation, which is connected by the sport cable to the on-land station, and then from there we get the energy to everybody who needs it. So why do we need to understand what is at the subsoil? Why do we need the geologists for this? That is a question that engineers, do a lot. Because we need to know what is below the surface, actually, because that has a big impact on the feasibility of the project, the design, and everything. So for everything, not only for the installation, because we're always talking about the wind turbine seating and so on, but the cable operations are very important too. We need to know what is in there because of the price, because sometimes maybe we cannot even do the project if the geological conditions are not adequate. So that's when we go. And so we need to create geological model. Why do we need to create geological models? Because actually we cannot have data every meter. So we need to deal with what we have. So the only solution is to make a model. So to create a model, we need data. From where we get it? So we can get it, for example, for the public, from you guys. So we can take the data. But what happens with this data? This data is mostly, sometimes it's cheap, accessible, and so on, very nice. So we can use it, for example, at the very beginning when we are at the concept of the project, to know more or less which areas maybe we may target. But when we go into more details, so this data usually provide limited information. For example, here we have a borehole. So yeah, it tells us that there is sand in there, but we don't know the density of the sand. We don't know the fines in the sand, which is very important for the engineers to estimate, for example, the production, how much fast, how fast we can trench, for example, for the foundations also, etc., etc. Those are important factors that usually are not provided in database, public database. Same for geophysical data. What happens is many times data is not digital, so we need to digitize it. When the data is digital, sometimes it may be for the petrol business. So the resolution is too low for the few first meters, so we cannot use that data. We need to reprocess the data, for which we need resources, for which we need money. So at the end of the day, time is money. So so this data, again, very nice to have. We need you guys to produce this data, but it's something that is it has a limited use for us when we work in these projects. So another challenge that we face is the time and the data storage. The time, because when we start thinking about these kind of projects, the first the first people who need to think about how to do this and where to do this are the geologists. So we need to be involved from the very beginning. And what happens is that politicians, engineers, and everybody involved in this, they want to have the information now. So we need to be fast. So we need to create models, and so time is limited. We need to work fast. We need to work together and be efficient. And then what happens is also that we're talking about large areas, so we need to have as many data as possible. So we end up with tens of terabytes of data for any project. Any wind farm projects produces tens of terabytes of data. So we need some place to put that data, obviously. So this is something to take into consideration. So another thing is uncertainties. We've been talking about uncertainties. We know about uncertainties as geologists because this is not this is not mathematics. So we need to deal with this. So For wind turbine generators, uncertainties are low because actually, we can have just a borehole in the place where we want to put the wind turbine and so on. We have seismic lines, whatever, so we can have quite a lot of data. There is always limitation to the data. We need to deal with this. We create risk analysis, gaps analysis, and so on to manage the uncertainty. Because most of the time what happens is that we decided to put the wind turbine here, but then they decide to maybe move it here. So yeah, the borehole was here. So yeah, we need to deal with this, but this is manageable. It's okay. For cables operation, uncertainty is a bit bigger because the areas are very long. Sometimes we are talking about tens of kilometers or even 100 kilometers or so to bring the energy to the shore. So yeah, we need to, we have data that are more separated and so on, but anyway, we work with this, we create our models, and so, yeah, this is just how it is, because 3D is something that I didn't say before. 3D seismic survey for this kind of project is still very expensive. And so it's we're still working with 2D. Hopefully, at some point, 3D will come, but anyway, it's not the case so far. Then what we need to deal is with geological hazards. For example, we need to know very well the mobility and the morphology of the seabed, because for the cable, for example, we cannot leave the cable just on the top of the seabed. That wouldn't work because we will have many problems with that. Here there is an example of a cable rip-off because of an anchor or whatever. So we need to understand this. So we need bathymetric data updated and also with high resolution. So from history, that we can put one on top of the other. So also there are here, for example, for superficial boulders, this is a very important one too, because it's a lot of, so it increased the price of any project by several numbers when we have boulders in the place where we wanted to pass the cable, for example, or we wanted to put one of the wind turbines. So we need to understand this. This is also quite important. For example, I see that there is a lot of data, bathymetric data, etc., but there is also backscattered data that is collected. Normally when you collect bathymetric data, you do also collect backscattered data, which can be used for this kind of analysis. For example, would be nice also to create a database where we can find this data and so on, side-scan sonar as well, whatever. But this is a hazard that we need to take into account, and which is relatively well managed because of side-scan sonar, etc., etc. And then another hazard, but this is more difficult. So the subsurface boulders, again, this is again a big, it has a big economic impact, because when you're trenching, you find a big boulder, it creates you a problem. And so detecting those are something that we're working hard to create new tools and technology to do this, because it's more difficult than the other one. But I hope that maybe with in the future, with the new IT tools and so on, we will be better with this, but we're doing our best. And so also where we have the geological hazard, obviously, the seismic hazard and earthquake and so on. This is also an issue that we need to address. And, it's always something that we as geology need to push ourselves to be even sometimes invited to discuss these issues with the seismic engineers and seismologists. And so this is something that we need to take into consideration also. And so we need to put effort and money and resources to solve this issue. And so those are all my problems that I deal with every day mostly. And so here I leave you just with a summary of what is this. So what we need is actually just good data and high resolution and ways to lower the uncertainty. That's it. Thank you very much.
Thank you, David, for this very practical perspective. I think it's good to hear that that obviously what we're producing as geological survey organizations isn't always enough. You know, there's more that is wanted, and you know, it's very good to also have this reach national governments, so that they know that we have great output, but we can do more and better fit for purpose work for these large-scale developments that are going on. So that being said, I would now like to start the panel discussion for Work Package 5, and I'm very happy that we have with us, aside from the two speakers, we have Zoe Konstantinou. She is at DG MARE, and she is, I think, the woman that now, following in good footsteps, is making EMODNet happen. Which to us as geologists, but also in a broader community with biologists, seabed mappers, habitat mappers, physicists, chemists, very important to us on the marine side of things in Europe. Like I said, she's with DG MARE, but she has a background as a marine scientist, and she knows everything about mussels, right? So, and then we have our work package leader. It's Eleftheria Poyiadji, and she is with what I colloquially call the Greek Geological Survey, and she is also the chair of the Earth Observation and Geohazards Expert Group of Euro Geosurveys. So she knows everything about risk associated with geology. And then finally, Gilles, very happy to have you as well. Obviously, director of the European International Affairs at Ifremer in France. Not anymore. Okay. Well, you're going faster than I can keep up. But at least it shows that you're very much involved in making this European work and activities happen. I'm getting and obviously.
I want to know where I'm working, so just the message.
Right, and obviously you're also at the European Marine Board, where you do very important work, making sure that we get not just good sort of policy input, but also these wonderful papers that appear every now and then. One was on coastal vulnerability not too long ago. So can I invite the others to the chairs as well, and then I would like to kick off with a first question, and that is, well, you're all involved in some way in coastal vulnerability and or offshore wind, and I would like to know from you, so how often is geology really sort of mentioned to its fullest extent in the meetings that you have and in the work that you do, and both in terms of coastal vulnerability and offshore wind, and what is the current opinion on the usefulness, we already heard a little bit about it, of transnational as well as pan-European geological data and data products provided by us as geological survey organizations. So, and I don't just want to hear strengths, but I'm primarily interested in weaknesses.
In wind farms, at least geology is really well represented because everybody understands that we are needed. I mean, nobody will take the chance of starting a project without invited a few geologists to complain or say, that is not right there, is maybe there. But still, this difficult is, we still need to, we struggle a bit, obviously, because we need to, we are not always the bad guys. We are always the ones talking about hazards, for example, and things like that. So that is always problematic. But we are big part of wind farms, and more. We are invited, we are listened to, and people understand that we are important. The other thing that you were saying about how these pan-European databases and so on are taken, and how they, so I must say that before recently, all these platforms were completely unknown by most of the companies that I know of. I started recently in this company, but talking with my colleagues, and when I arrived, because I was working before at the Geological Survey of Belgium, I arrived already with this knowledge that all this existed and so on. So immediately we were in going to the databases and try to get the data and so on and so on. But I know that it's a recent thing, so I think that this is something that has to be still advertised and push, but the knowledge is there. So.
In my case, well, this is what we do. We talk a lot about geology, not only in the scientific community, but also in the public. It is not always going well. From time to time, what we as geologists are saying, it looks like out of space. It has happened a lot in my life. And this comes very close to what it was discussed before in the other panel, that we need to communicate. We need to communicate what is important, what we are doing, what solutions we may bring, and why some things that goes so wrong in our society are not have not taken into account the geology. At least in countries with a lot of hazards, it is so really obvious. And about the data, yes, we use a lot of the data from the geological societies, because everything is based on the maps and what you have very well developed. There is a lot of work still to be done, different kind of scales, more data to the data gaps and so on. But I'm pretty sure that we have a lot of things to do. We are still working on that. You are still working on that. And as a society, we have a lot to bring to the public. I think we are not very good in that. Maybe we talk a lot to each other, but not a lot with the public. And this has created a gap between the geologists and the society. This is my opinion.
Okay. First of all, I would like to thank you very much to have invited me here. And I'm very pleased as a marine geologist to see that the Geological Survey are working very well, and I was very pleased to hear the presentation. So to tell you what I'm doing now, and that could be pleased for Christine from BGR. After Macron, maybe you know Macron is the French President of Republic, speech about the ocean science, the Prime Minister and his General Secretary of the Sea discovered they have no knowledge about science. So they asked Heteren if they are an old guy at the end to be retiring, a senior scientist, they call that, to advise them what should be done and what is the ocean science. And so I was proposed, and now I work for the General Secretary of the Sea, and we have concern about the development in France of ocean wind farms, deep sea research, coastal vulnerability. This is subject we are dealing with every day. And I can tell you, in front of the different change and turnover of policymakers, it's not easy. And even if you talk, it's not easy. And I'm very pleased, and every time it's like this, you are the geological community, and you talk to you, but somebody don't know you. And in fact, in ocean science, the strongest science community is physics. Why? Because of the climate. You know, the ocean and the forecast can bring you the information with the conveyor belt, the currents, the information on the heat of the ocean, and so on. It's the physicists, they are dominant. After, the biologists, biodiversity, vulnerability, and environment. And geology No. So when I talk about the geology, because I am a geologist, and I've been working for 2 years in an oil company, so, and it's difficult when you do that, to do site survey assessment for rig, pipe, and cables lying on the ground. And it's funny to see the difference. At that time, they had the whole company has a lot of money. And you can see with what has been presented by the Netherlands with Shell and the Dutch, they could develop, as our Irish colleague has noticed, a very nice data collection and GSI, which is very high level. But to install the wind farms is less money. Maybe when the insurance will have to consider when 2 or 3 wind farms will fall down, or one ring with cut, one anchor will cut 100 cables when it will move away, then they will decide to do better site survey to be sure where they are, or when they will put one in a big hole that will in a karst system when the wind farm will disappear. That will be considered. But for the moment, no. And we have a problem in France, and I'm talking about France, is about marine spatial planning. Before you do and you install the offshore system, and we heard that we need this energy, you need to have a consultation about the different actors, fishermen, tourism, industry, and you need to know what is on the seabed. And that is very difficult. The sand is the reason why I've been a marine geologist, because most of the seafloor is sand and mud, and it's very easy to decipher compared to all the metamorphic rocks and so on. So that was easier for that time. And in fact, that is the big questions. How reliable are the maps you are using? And I thank EMONNet. We use EMONNet. I've provided a lot of my data. When I'm 30 years old of research in Ifremer, I do a lot of mapping, and all my data are accessible in EMONNet. It's not my data, it's Ifremer data, the government data, because they pay for it, but acquire with the vessels. And sometimes when I see the people using it or coming it, the resolution is not what we expect for that. We have the map, we have a nice map, but we don't have the real resolution. So we have a lot to do. Make better understand what is a geologist and what is the use of geologist. But you have said that already. When I arrived in Ifremer as director of European International Affairs, I was one of the 50 geologists of Ifremer, over 700 scientists. And the scientific director was a microbiologist. And she looked at me and she told me, you are a geologist. You are destroying the earth with the oil and gas and the raw materials. And I say, yeah, but your shoes are not all leather and made of caoutchouc from EVA. So I don't think they're all natural. So you have a little bit of oil on you, so take care. And you are in a building where it's made of sand. So I don't know, maybe you have to go ask for a building made of wood. But you have to, you need a lot of the geology. And I think this is something we have to go for, especially for the mapping, on the seafloor mapping, to have a better resolution and try to have permanent fundings, not only rely on the science, because they use the data coming from surveys where study, for instance, sand waves, formation or movement in the North Sea. And all this need to better things. And I stop there because I speak too much. So.
Okay, then I will continue. I will try to be more short anyway. This is very difficult because I am 35 years engineer and geologist. And in my job, I learned to translate geology to mechanics, to engineers, because they are not used to listen just, this is a limestone, it's from Cretaceous, or it has some fossils in it. They don't want that. They just want to tell them that it is a rock, you can build on it, but you have to look for that or the other. So in my long experience, I learned that only after big disasters, they take geology seriously. In Greece, in 1995, we have a great landslide that cut off the main road that was connecting Athens to Thessaloniki, the two major cities. So they did understand that in order to have safe roads, they must do geological works and geotechnical works afterwards. So yes, but we have more work to do. 2 weeks ago, I was in the field, and I was looking the disaster from flooding and landslides occurred in a great part of Greece. So in a place that was not a river, it was a beach. Many houses were destroyed completely. You cannot find them. They went in the sea. So much water. So somebody asked me, who gave the permission to build there? Well, they don't have, in the planners, in the cities, they don't have geologists. They don't look the geology in order to give permits to build. So this is our duty to say to policymakers that you need to look geology for urban development or for coastal vulnerability or anything else, or for, I'm sure that if you are going to construct a major work, a technical work, you are looking geology because you are losing money. But for just giving permits for a house, sometimes this is not the case. Thank you.
You started with a question if the geological data are being referenced in different settings. So it depends on the settings, because if you speak with people that represent the offshore energy companies, you're going to hear about geological data. If you speak with people in the high-level policy making, you're not going to speak about geological data. The interest is not in the data and in the information. Martin in the previous panel has already mentioned it. Policymakers don't care about data, they care about results, and the results are usually related with some kind of cost and some kind of benefit in terms of money or in terms of impact. So to bring, I don't look only into geological data, and I feel that we need in the communities, in your community, in the physical community, in the marine community in general, to have a more integrated approach, because as Gilles said before, okay, the physical community really leads in the marine sciences, but the physical community, if they want early warning systems that provide information on coastal vulnerability, need geological data. And at the same time, you need the physical community in order to be part of these developments and have this kind of understanding, provide this kind of understanding to society and to policy makers on coastal vulnerability. So we need to work together, the people that are looking into data, I feel. And then what is needed from your community and from all the other communities that are related with data is to change the narrative of communication with policymaking. We have to stop going to policymakers that have no direct understanding, because it's not their job, to how data is used, trying to use these arguments. It's regardless the effort you put in the education, it is not going to work. As well, it's not going to work to speak to all the public about the benefits of geological data. The battles need to be chosen, and they need to be curated very specifically to give the impact of this kind of data to the correct audience. And this means that some of the scientists in geology science, they need to leave science behind and become communicators. And not everybody can do this. There are specific people that have the talent and the capacity to do so, and these people need to be trained to do this job. And we need to change the narrative. We need to explain to local, to regional, to European policymakers, what are they going to win in terms of impact if they invest. And they don't need to know exactly in what they are going to invest. They don't need to know that it's going to be this and this type of sun. They need to understand that an investment is required for specific impact to happen. This is what we can tell you with the knowledge that we have now. But if we had more, we would be able to give you not no uncertainty, but a better level of certainty. And you could invest better, you could have benefits, you could have saved communities, saved your infrastructure, win money, and win societal acceptance from this. So this is how I think we should frame this discussion.
Well, thanks very much. I think I learned two things. One is that marine geologists and marine scientists and marine people in general take a lot longer to answer a single question than terrestrial geologists. But the other one is also that there's still a lot of work for us to do, and especially on, like Martin said, on meeting the people who are using our data. And I think we are still sort of we're pioneers. The sea is still this unknown land, so we're a little bit late at the scene. So that's something we have to deal with. And because we're pioneers, we've been very much focused on just making single generic data products. But now we really have to move to output that will immediately help people solve their problems. So if we can make that happen as part of this 5-year project, or at least take a first step, that would be wonderful. And I think with that, because I got a warning sign from Francesco, we'll release you, and I think I have a few gifts to give.